This is the third video in the Smartphones and the Astronomy Classroom series, which will focus upon our experiences with using these simulations in the classroom and specifically describe how we direct students. We refer to this as first practices because we are very early in the learning process of how to reap the benefits of student smartphones, and there will need to be much more experience and quite a bit of research before we will know enough to describe best practices. A quick response code is a two-dimensional scannable barcode that can store information. They have been used for several years in newspaper ads and on the back of business cards to encode URLs, but their usage really took off when QR code readers became linked to smartphone cameras and used to direct a browser. This capability has been built into popular smartphone cameras since iPhone and Android 8 models. Older phones will need to install a simple application. Note that there are many websites where one can generate QR codes. Just Google QR code generator and simply enter a URL into the site and download the corresponding graphic. Thus they are easy to make and easy to place on a PowerPoint slide or paper handout. Here we encode our main smartphone simulation web page. QR codes are our main tool for directing students in the classroom. If you haven't previously read a QR code with your smartphone's camera, you are encouraged to give it a shot now. One concern that we had early in the project was, would student smartphones be able to pick up a small QR code on a PowerPoint slide from the back of a large lecture hall? On several occasions I have asked the students in the back row if there had ever been a problem or challenge, and they have consistently stated all good. I see no reason to probe the minimal size limit where detection problems would start to occur. It is important to provide clear direction to students on tasks to be accomplished on their smartphones. Here we provide a formulism for accomplishing this on a single PowerPoint slide to be projected in the classroom, identify the necessary components of the slide, and describe what each accomplishes. Provide a clear descriptive title for the activity, like Star Trails Explorer Directions. Provide the quick response QR code with the website URL to the simulation encoded. Provide the actual URL to the simulation. Although 95% of students will read the QR code with their smartphone camera, there will be a couple of students using laptops, largely because they utilize them in another class. We have observed that students typically search on Google using the title or a portion of the URL rather than typing in the complete URL. Provide a screenshot of the simulation, which will give students complete confidence that they have arrived at the right place. Provide or write out a short list of questions or objectives for students to accomplish. This is vital for simulation use. We want them exploring, but in a focused manner. We typically add a verbal focusing directive like, please tackle the following questions with your group, and we will debrief in 10 minutes. Here is an example slide used to direct students to our Planetary Positions Explorer. All of the elements described in the previous slide are present. Descriptive label, QR code, URL, simple screenshot, and specific questions embedded in the simulator. Although this Explorer is eventually quite sophisticated, this usage focuses on simple introductory aspects of the nature of the solar system, and it was used very early in the course, which explains the extra paragraph near the top. Here is an example slide used to direct students to our Eclipse Explorer. This sequence focuses on the different types of shadow, how they lead to different types of eclipses, and whether a total or annular eclipse is seen depends upon the angular diameter of the moon. Although there are 6 questions here, they are quite interrelated and go quickly. When actually used, I remember giving them a little more than 10 minutes, but my debrief was pretty quick and focused upon identifying the lunar distance at which the angular diameter was the same as that of the Sun, and the significance of the moon being a little closer or a little farther away. Here is another example slide used to direct students to a first usage of our Star Trails Explorer. This slide has an additional comment near the bottom, as it was their first interaction with a state question with a setup button hiding some controls. We have also made use of smaller and simpler PhET simulations in this manner, largely for introductory concepts such as gravity. Writing out a few questions or tasks for students to complete works well. Here is our direction page of the Gravity Force Lab Basics simulation. Note that PhET has many sophisticated simulations that don't work particularly well on a smartphone. We are sticking with the simple ones at present. Here is a similar page for the Coulomb's Law simulation. Here's the direction page of the Build an Atom simulator, which uses an embedded quizzing feature of the simulation. Note that writing out the questions or activities here works well as long as it is kept brief. This can also be done with the UNL simulations, or you could mix and match embedded questions with ones that you create. We have also attempted to use the simulations from other organizations on smartphones with limited success. Special care is needed to make simulations that handle the limited screen space and varying dimensions of smartphones. Note that this pedagogical approach was tried out for the first time in the classroom in the fall of 2021. Although we thought it was likely to work, we weren't completely sure until we put it into action. We were surprised that we really encountered no significant issues, no bandwidth, code compatibility, nor QR code issues. There were some minor layout issues for some simulations on some devices, which have mostly been conquered since. But students deal well with that, better than faculty do. We are very sensitized to the issue of a student who does not have access to a mobile device, not wanting to be furthering the digital divide. And we encourage students to contact us before the term started who anticipated device difficulty. We also looked extensively in class to identify students who did not have a device in class, and we continue these practices this semester. We have yet to identify a single student by either approach in both our Introductory Astronomy and Astrobiology courses. More on that in the next video. This video isn't entitled First Practices for Nothing. It will be a while before we have a complete understanding of the best practices for using these tools. And yet the only way to get to best practices is to start doing these things, observing carefully, learn, and make adaptations for the future. Time allocation will vary between classes. We recommend making your best guess and make subtle changes on the fly. If you think that students need a couple more minutes, give them that time before calling them back to the group. If your launching directions say, "We will debrief in 10 minutes," no student is going to time you and hold you to that. In general, we found that smartphone simulation usage was pretty efficient. All of the time spent reading directions and writing out responses in other formats is available for exploration here. We have so far left the collaboration directions to students, the somewhat vague "work with your peers," and anticipate specifying a more specific verbalization protocol in the future. This could take the form of once all students have explored an assigned question, someone in a group takes a stab at explaining the solution, and the other students then refine or challenge their solution, or if they have solved the task in a different manner, illustrating that approach on their smartphone. However, it should be noted that compliance was extremely high. We observed students eagerly getting out their smartphones and exploring on them, and are moving slowly before complicating something that is already working well. I often have a short debrief afterwards on an important aspect that I want to be sure that students don't miss. Often this segues into a related topic where I build upon what the students have explored in the simulator, so it is as much about transitioning to the next topic as going over the last one. So all of the challenges that remain involved creating more simulations, developing and improving questions, and more effectively blending this pedagogy into the fabric of what we are already doing in the class. The core technological and pedagogical issues are going well.